creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. On today's program, we're going to be looking at the evolution of computer hardware, from mainframes to minis to micros. We'll see some examples of the oldest mainframe computers, and we'll take a look at one of the newest microcomputers, the HP 150 from Hewlett-Packard. Gary, are we at the end of the line in the evolution of computer hardware, or are there major new phases of this evolutionary process still to come?
Well, fortunately, we're obviously not at the end of the line. We're at some point in time in the evolution of using, let's say, microprocessors as general-purpose computers, and they're just getting smaller, faster, less power, and most importantly, they're less expensive than they ever have been. I guess the logical conclusion is they get so small that you lose them like you do your keys. But as far as evolutionary trends, there are a lot of new things happening with microprocessors, use of microprocessors as controllers for, let's say, intelligent devices such as a wheelchair that finds its way around and, under microprocessor control. So I think there's a lot of exciting things that are going to happen that will be off the mainstream of using computers as general-purpose computers as well.
Okay, to start our look at the evolution of microcomputers and mainframes and minis, we went to Boston to visit the Computer Museum. Established in 1979, the Computer Museum houses the most extensive collection of early computers in the world. Its galleries feature some of the earliest known calculators, like the Pascaline, invented by the French mathematician Blaise Pascal in 1642. The Pascaline stored numbers on 10 little rotating dials. Moving one dial up to 10, moved the next dial one notch, and so on. It was the first consistently reliable example of a computing machine. In the late 1800s, Herman Hollerith devised a card punch calculator to speed the tabulation of the 1890 census. The cards were hand-punched, but electrically read, a concept that showed up much later in the earliest IBM machines and is still used occasionally today. The forerunners of modern computers didn't appear until the late 1930s and 1940s. The Whirlwind, of which only a few parts remain, was a massive machine, covering 3,000 square feet and weighing over 3 tons. The heat given off by its 18,000 tubes required constant monitoring, and in spite of its great mass, the Whirlwind's processing capacity was about the same as a present-day 16-bit microprocessor. It was not until the invention of the transistor in 1947 that a new era of smaller, more efficient computers became a reality. This is the TX0, the world's first general-purpose computer using transistors. And it still works. We'll see a demonstration coming up next.
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
On today's program, we're going to be looking at the evolution of computer hardware, from mainframes to minis to micros. We'll see some examples of the oldest mainframe computers, and we'll take a look at a half-inch tape drive. And it even featured a video game program involving a mouse with a memory, threading its way through a maze to reach a piece of cheese.
TX0 was built at Lincoln Laboratory, and the notion was to test two ideas. One was transistorized circuitry, and the second thing that it was designed to do was to test a very large memory, and it did that very well. And then it was used. Then it was moved to MIT for real use. But its role really was a circuit tester and a memory tester.
Displayed in the Computer Museum's lobby are some of the biggest solid-state machines ever made, supercomputers. The IBM Stretch, Control Data 6600, and the ELIAC 4 represented the most powerful class of computers of their time.
Well, the ELIAC began with some ideas in the early 60s for doing a lot of computing in parallel. And the idea behind ELIAC is to have a number of processing elements. In this case, 64 processing elements, each with a small amount of memory, and then to have a single instruction that executes, that operates on all of that data in parallel, so that in fact you get speed by this massive parallelism. ELIAC's main effect was as byproducts to they stimulated the use of semiconductor memory. It also stimulated the idea to make faster machines, and the fact that fast machines were really important in a whole bunch of applications.
The development of integrated circuits paved the way for faster, smaller, more powerful machines, and the mini-computers of the 1960s. But what was considered small in those days bears little resemblance to what we call personal today. Some people consider this Link computer to be the first truly personal computer. It has a keyboard, it has a CRT, it even has mass storage devices, but this part was only the terminal. This, in fact, was the computer, and in the days of this computer, this was considered portable because it was on wheels. Mini-computers were a major breakthrough, equaled only by the appearance of microcomputers in the next decade. Progress in very large-scale integration of circuits promises even further size reductions and increased processing capacity. But the future holds more than just a change in the relationship between power, size, and speed.
Well, I think the next sets of challenges that we have right now are going to be integrating video and television and voice into machines, and I think that those are beginning to happen to a reasonable degree, and maybe I can't predict whether the video disc will come in or not, or whether that kind of how important that technology is going to be. But I think just the notion of storing pictures and operating on those pictures, that's kind of the next frontier.
Herb Lechner has joined us. Herb is Vice President for Information Systems and Administration at SRI International. Herb's got quite a background in computing. It goes back several years. I understand you programmed the ENIAC at one time.
Yeah, that's right, Gary.
So, our title is Mainframes to Minis to Micros. Could you give us some idea, just for general information, what these different kinds of computer systems are all about?
I'm not sure, Gary, that there is a precise definition, because yesterday's mainframe is today's micro from a performance point of view. But I think that we normally think of the mainframe as being the faster, high-end computer system that we find in scientific research. And we certainly think of the micro as being a personal computer which does one application at a time for one person. And somehow or the other, the minis get kind of compressed in between.
In talking about these three different types, Herb, will three different kinds of computers continue? I mean, is there a reason to continue to have mainframes and minis and micros, or do you see like micros taking over with the kind of job that minis did in the past?
I think we'll continue to see the spread both in the high end and in the low end of the computer line. There's a constant demand for faster and faster machines. The Japanese fifth generation objectives is a clear evidence of that. While at the same time, now that we have broadened and matured the computer field to encompass the home and the office and the individual, I'm sure we'll see a push to the downside also.
In fact, if you take a look at just some of the recent developments, I guess, in microprocessors, there's quite an emphasis on data communications to mainframes, getting at information services, and this seems to be some sort of a coupling of the mainframe use with the microcomputers. So there's some synergism there for sure.
That's right. Some people have commented that the advent of the microcomputer is merely a spreading of the components of the mainframe system over a larger area.
Speaking of synergism, Gary, I'd be interested, maybe both of you could talk to this, because CPM is one key factor in what I'm about to ask you. Was there a synergism between operating languages, operating systems, or software in general, and the evolution of hardware?
Well, I think definitely the software has played a key role in the evolution of hardware. And in the markets that these various classes of machines service, I think we see that very clearly. In the mainframe area, the more powerful computers with many more peripheral devices and disks and tapes will service multiple users at the same time, and the software has to be massive and somewhat complex to support that. Whereas in the small side, we're seeing a trend towards simpler software, easier to use software that services the needs of an individual.
Well, I think also at least in small computer evolution, it's been an evolution that's been paralleled the large computer systems and mini computer systems to a large extent. And I think that nowadays there's some breaking away from that. Mainframe world is many times batch or time sharing oriented, and now with small computer systems we're looking at more of an emphasis on, say, real-time control, more the kinds of things you'd find in an industrial control environment or even in a home. So there is some, I think, differences there. There are some differences that are starting to show up.
Yes. Yes,
Herb, not trying to date you, but you were with IBM in the 50s, I mean, the early days of this stuff. I'd just be curious, did you guys envision at that time that in the early 80s computers would be where they are right now and that we'd have made this kind of progress, this kind of evolution?
Well, I certainly didn't. And I can recall in the days of the 702, we wondered if we would ever sell 30 such systems in the entire United States market. So clearly we did not have our sights set on the proliferation of computing we've seen today.
Well, it's interesting. Just the other day I saw a small computer system. I can't say exactly what kind it was, but it was running PL1, and it was the kind that you can put in your briefcase. So there definitely has been some change in the characteristics of computers.
Yeah, it's a walk down nostalgia lane to see the museum and think back to the days when we had an installation team of 17 people sent out to install a computer over a year that my kids handle in their spare time.
Okay, speaking of the newest thing, in just a moment we're going to take a look at one of the newest examples of a microcomputer, the HP 150. It's a computer where your fingers can do the talking. Okay, joining us now is Cyril Yansounis. Cyril is the general manager of the personal computer group at Hewlett-Packard. And Cyril, we mentioned that the HP 150 is a good example of one of the newest microcomputers in the field. Maybe you could run a demonstration program for us and particularly point out the new technology aspects of it.
Yes, I'd like to do that very much. I think when we set up to design the HP 150, we had in mind the professional user, but the user who is sophisticated in the use of information, but not sophisticated at all in the direct use of a computer tool. So we really focused on developing a technology and a total approach for a very intuitive use of a personal computer. And what we have embedded in the HP 150, the most visible part is what we call touchscreen capability. The fact that you can interact directly with the personal computer without accessing the keyboard by basically using what is the most intuitive tool that you have, basically using your finger to point and select objects or select things on the screen.
Could you show us with what you have up there?
I would like to show you what we have on the screen there. What we have on the screen there is what I call an electronic Rolodex. We all are very familiar with the Rolodex on our desk. It's a set of cards, and you can turn wheels back and forth until you see the right name, as an example, appears in front of you. We can do exactly the same thing here. I have an electronic Rolodex. It appears very much like a Rolodex on the screen, and I can move it up. I can move it down just by pointing on the wheel on the screen. I can go and select a name. Let's suppose that now I have the set of names and I want to select a name there. I have Stuart Chaffee name there. I can just select that card, and the Rolodex opens there, and I get all the information that I have embedded in the product on Stuart Chaffee. I have his address, his phone number, and so on. As a matter of fact, if what I want to do next is call him, I just indicate that I want to dial the phone. And if I had a modem attached to the product here through a phone, I would automatically dial the phone. So let's go back to the Rolodex. And you can see then I can really roll it up, and I can roll it down, and I can do quite a few things. You can recall, again, just by pointing the application. I can recall the specific program what I could have selected, again, just by pointing to the screen, another application.
Touchscreen is not really new as a technology. It's kind of a new application of this in this computer. Is that right?
That's absolutely true. Touchscreen is not new to and it's not a new technology. It has been used on terminals mostly as, again, a pointing and a selection device. What we have done there is really embedding very well the touchscreen capability of the product with the software, with the application, and really trying to see everywhere we could replace keyboard access by basically pointing directly to the screen.
Cyril, do you see a shift from using a keyboard to using this touchscreen display? For example, we have lots and lots of applications that are written for small computer systems, and how are you going to get all those programs to move over to a touchscreen?
Okay, I think that the way we have designed the product, in fact, is by allowing very simply current and existing application to basically use a touchscreen capability. The product itself has built the ability to recognize if you are putting your finger and really selecting either a specific place where you want to put your finger on, or an area where you have your finger in that specific area. So you don't really have to burden the application itself by all that. It's really basically replacing the movement of cursor. Okay, but again, instead of having to move the cursor with the keyboard or with any other device, you can really point to it directly with your finger.
One of the criticisms, though, has been that holding your finger up there in your arm would be kind of tiring. In fact, I heard somebody say that there was an attachment they thought was going to come out for the HP 150, which is a little armrest, and hold your arm up there while you're touching it. Is there a problem with that, or is that just a rumor?
All the studies that we have made, and we have very extensively tested the product, obviously, before we put it on the market, show that this is really not a true problem. You don't really spend a lot of time with your hands up there and pointing to the screen. I have myself a pretty good feeling that the ideal user interface, as a matter of fact, doesn't really exist. It's really going to come out of the combination and a lot of experimentation of a lot of the user interface that today exist, like touchscreen, like ability to move a cursor through a mouse or a tablet, probably one day also using voice. And I think it's going to be a combination of all those different user interfaces applied to very optimally to some specific type of application. I think there are going to be a good matching of the kind of user interface with the kind of application. So I think it's going to be a combination of all those user interfaces which are really going to make another step forward in user friendliness.
I see two things looking at that machine that seem new in technology. So you've got microfloppies on there rather than the traditional 5 1/4 inch, and I was wondering if you could comment on that. Also, there's a printer sitting in the monitor, which is something I haven't seen before.
That's right. I'd like to, maybe I'll start by the printer and then we'll go to the microfloppy. Let me give you a good example of the nicety of really having a printer built in. As you can see, as a matter of fact, it doesn't even appear. It's really built in the product there. It's user installable. It takes a minute or two from any user to basically receive his printer and put it and install it in the product. Let's take a good example. Let's suppose, in fact, I really want to go back and reselect this card. It's, again, your card stored. It has information. I'd like to have a hard copy of that information. I'll just go and say print card, and my printer is really going to start printing that card, and in a couple of seconds we'll be able to tear it out there and give it to you. The microfloppy, it's an area where we also believe there that we are kind of pushing the technology. We're using, as a matter of fact, a 3.5 inch technology, and I think that I have one in my pocket here. It is a kind of semi-rigid microfloppies. It's, as you said, different than the 5 1/4, but has today basically the same density, the same capacity as a bigger 5 1/4 disk. As time goes on, as a matter of fact, we think over the next several months, we'll see significant improvement in the capacity of those products, doubling and even quadrupling the capacity of those microfloppies, probably even getting to the range of a megabyte that you can basically carry with you. This is really the ideal, we think, personal mass storage media. We have also seen tremendous reliability improvement using those kind of product, and one can really see why. The semi-rigidity, the fact that it has an auto shutter, so in some sense you never have outside contact with the media itself.
Herb, we've seen an example that Cyril's been showing us here of one of the newer versions of a microcomputer. Where would things be going after that? We talked with Gary at the very beginning of the show about what's the next step. It will be in the direction that Cyril mentioned of more user friendliness, as we tend to say. What's the next stage in this evolution of hardware?
Well, I think that there are a couple of trends that we see evolving. Clearly, making the computer easier to use and making more software available that is easier to use is one of the trends. Another trend seems to be, especially in the business environment, networking the computers together. Because given your own computer and being able to do many things on that computer, it seems like this almost commands the next step as being, now let us interchange data between computer users, and we see the local area networks and networking becoming a factor.
I would agree with you on some of those points. I think that most of the networking, though, is going to be more in data communications over telephone lines, that is, linking the office with the home and things of that sort. We have a tremendous network throughout the whole world that is based on telephone system, and I think we're going to just see a lot more evolution in that direction. But LANs have had a lot of problems in just setting up the networks, and they're very expensive. So, but I agree with you.
I agree 100% with that. I think that, in fact, we do have this network system, which is our telephone systems. I also think there is another reason, in my opinion, we're going to see this very good matching between telephone networks and computers and personal computers, is the integration of voice kind of capability.
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
On today's program, we're going to be looking at the evolution of computer hardware, from mainframes to minis to micros. We'll see some examples of the oldest mainframe computers, and we'll take a look at one of the new...
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.